try. We can connect and speak about this thing now. So look, here we have the empty project, but we can try to do the following. I can upload here, not that one, but I can upload. I can show you another one project which is already prepared, and we can try to go through the code to understand how it works. This would be interesting, and then we can try to create our own projects with these things as well. So here you can see there are so many different projects, and one of the project is nice that it is coined with the servo motor. So you can try to have the electronic safe. You can see here, this is a very interesting project. And you see here, there is a lot of code. So today, basically, I will try to explain you how it works so that you can feel more sure about different codes. And then later we will try to create some kind of similar projects, but which are like not so complicated. So you can see here we have basically a lot of components, and one of the component is the LCD screen. This is a very interesting thing. Oh, sorry, something have stopped sharing. And this is a very interesting thing. Do you see the screen? I hope you see the screen. Yes. And so this is the LCD screen, and LCD screen allows you to work with different levels. You can see here are little dots like pixels, and we will try to understand how those pixels work. Then here we have also very interesting thing like servo motor. So this is the motor which also has three connections like potentiometer, and you can see that here is the ground, here is the voltage, and here is also the so-called PWM. This is the pulse width modulation. And we have a keypad, so this is also a nice thing that you can just put on the numbers, etc. And let's see how the project works. So this is basically an electronic safe, which gives you an opportunity to turn this lock, say so. And this lock is in one position it is locked, in another position it's open. So if you run the project, you can see it makes you like welcome Arduino safe, and here you can see if you want to lock, you can just press this one, and you see if you press this button, then you need to enter the new code. So if you enter the code, for example 0000, then we have to confirm the code like 0000, and then you can see that the safe is being locked. So it means that the safe is locked and the safe is there. So now if we want to try to open the safe, so we can try, for example, to enter some wrong code, and we see safe locked, so access denied. So it makes you like the possibility that the access denied, and it shows you the progress bar, which basically gives you some time to think about the new code. And if you make, for example, another code which is again wrong, then again the safe is locked and the access denied, and you have even slower. You see, so you have to wait again. So this is specially made so that you cannot have a lot of time to guess code, like in the phones usually. Yeah? But if you enter 0000, then the safe is unlocked, and you can see that now you have to enter the new code. It's just the safe like it works in hotels. When you have in hotels in the room, sometimes you can put something on the safe, and it does the same way. So here we need to understand the next thing that I can explain you how this complicated project works, because from the first time it looks very complicated, but if you look at this carefully, you will be able to see that it is not really complicated. And the thing is that if you are going to speak with, if you're going to work with microcontroller programming, you will be able to deal with different devices. And these devices also are important to understand how they work, what they do, etc. And each device is very hard to program, especially if it is quite complicated. For example, if we have the LCD screen, to program the LCD screen, it's quite a challenge, of course, because we have to know what does this. And you see there in the LCD screen, if I stop the program, here I can stop the program here. If I stop the program, then you can see that here in the LCD screen, you have a lot of pins. You have VS, VDD, and RS, RW, like E, and many different data cables. And these all are connected, and you need to know where to connect. And of course, you cannot guess where to connect because it is important to read documentation. So if you buy such things like LCD, there is always a little document coming with this so that it explains you how to connect LCD to the port, and how to connect what every pin means, etc. So you need to be able to find the document, or it should be coming together with your device when you buy it. And the same is happening with this one. You can see here are 8 different pins, and those pins are located here and here. So you need to understand how the keypad works. Actually, keypad works very similar, and so on. And here you can see also the servo motor. So the servo motor is a very interesting device, but it is easy to understand how it works. So let us start to see the code. And in the code, first of all, you can see that this is basically some kind of predefined software already. And let us analyze the software. So here you can have a lot of different things like libraries, because if you use, like in this programming language, the library. So you can see here is the hashtag and include. It means that you have to use some kind of basic library. You can see you can use the library liquid crystal age. So this is about how to work with the liquid crystal display. And if you have the library, this one, then you can use, for example, such things like definition of a liquid crystal. And if you use it like this here, you can use the liquid crystal library. And if you go further, you can see here there are different things. Here is the server. Here is, for example, LCD, and you can see the LCD is defined somewhere here. So you can see LCD. This is the defined here LCD. So and then you can see that here you can say LCD set cursor, LCD set cursor. So this actually function is used because you attached the liquid crystal library. So without liquid crystal library, it's not possible to work with this, and you have to understand it. So what is there? You can see that here afterward there is a lot of different, like LCD set cursor. Here is the LCD print. So this is the function which gives you a possibility to print something on the LCD. Here is like also LCD print, LCD set cursor, LCD set cursor, and here you can see also LCD set cursor. And there are different functions that you define. So basically, you use one and the same all the time in order to, let's say, have some new code. So actually, those things are easy to understand, and we will go through them. But you can see a lot of things are done with the LCD. So here you can see LCD write. So you can have some kind of icons, and you can see here you have icon unlocked character. So these kind of icons are available because you are using the special library which is called icon sage. And if you use the library icon sage, you can have a lot of different things. For example, you can just copy this icon age, and if you just copy this case and enter it into Google, you can find, for example, what kind of icons you have there, and you can see there are so many different icons, but we need to see the documentation. So I don't know if it's the right one. So we can write, for example, C plus plus or something, and then we can have you can have different here. For example, you can write WOKWI, and yeah, so library, and then you can say here we have this save, but it should be somewhere the list of those items. So you can say you have Arduino simulator. Here you have the libraries. Yeah, you can say the icon sage, but you need to somewhere speak about this icon sage, and then you can see the different things. And here, these are the icons. I can show you later how you can create different icons in the LCD. So this is the thing, and if we go further to here, then you can see that apart from the liquid crystal and icons library, you have the library called keypad, and you can see the keypad is the thing that is here. In order to use keypad, you also need to use the library called keypad, because then you will be able to sell some things. So here, for example, here you have, for example, keypad. So if you want to use the keypad, you need to define the keys, and you see here character keys. Here you define basically the idea how you connect the keypad. So you then have to know that here are 16 keys. You know, in the keypad you have 16 keys, and those 16 keys are here. In order to make them the same, you need to find those values. You can see here you have A, 2, 3, A. But it depends on what you write in those things, because the keypad itself can have everything here. But the important thing is that you create the keypad character array. And here you can define what will be displayed if you press a certain key. For example, if you press here instead of 5, you can have here some kind of different character. Then when you press this button, you will display exactly this character which you will program here. And here you can see also the special kind of row pins and call pins. These are the things which you are using because of the keypad library. And here you can define the connection pins. You can see that there's a connection pins for the row. So it means like 5, 4, 3, 2, and the connection pins for the columns. So you have to connect those pins exactly to those. And then now you are just programming which contacts are responsible for rows and columns, because afterwards you can create the character map like an array, and here you can say the keypad calls and keypad rows. So then later you know when you just press a button, you know which pins you activate, because you have to define them for input, and then they do that. And you can see here you have this, because of the library, because of using this library, you can define the keypad object, which is called keypad. And then you have a keypad make key map. So you just make key map out of this. And here you can see you basically have row pins and call pins. It means this is the amount of this arrays, byte arrays, and here you have the number of those things. So here are 4 and 4, because you can have different keypads, but this is how you do. And if you do this, you don't need already to care about what is inside this keypad structure, how it is programmed, because you're already using the library. And of course, if you want to do it from scratch, you can do it, but it's much more complicated. Then, as to the keypad, this is all. And you just using the keypad get key. So also this is the function which is available in the library, and you can use the function get key in order to understand how to make basically how to understand which key is pressed. And you can see when you have the key, so here you have, for example, if the key is larger than 0 and the key is smaller than 9, then you just press like this star, so it means like you're just making the password. And that's all. So here also you don't have something regarding to the keys. You have only the keys in certain places. Here you have, for example, keypad get key. So here you have it like that, and so on. So I hope it's understandable as well. And the next library we are using is Servo H. So Servo H is also the library which allows you to operate with the servo motor, because servo motor is having also special functions. And then you can see that you can have server, you can see server, and you can create an object which you call like log server, because it's like the object which will operate with this engine. And you can see here, if you want to do that, you need to have the server right log position. So if you go to the server log position, you can see that this is 20. So what does it mean? It is 20 degrees out of the initial state. But here, server unlock position, it is 90 degrees. So here, basically, it is at the moment 90 degrees. But if you want to move it to the 20 degrees, you can move it like this. So if you just modify those degrees, then this one will be moving from here. Here is 0 degrees, here is 90 degrees. And if you put, for example, here 0 degrees, you can try like this. If you lock, if you start this, you can see now we can have the uh, we can have to lock, we have to press the hashtag, and then we can try to do like this. We can try to do like this, and you can see it goes automatically to the 0 degrees. You see server lock position now goes to 0 degrees. So it means that you have called it like 0 degrees. And here unlock position, so 90 degrees, it is just the position by which you have to rotate. As I told you before, a servo motor is the special kind of device which allows you to precisely locate the position of the hub. And it is very widely used in robotics, it is widely used in medicine, and these motors are very expensive because they are so-called very precise and nice. They can be used also in smart homes, for example, for regulating your heating, for regulating the water supply, for regulating some kind of other taps or different things where you need to scroll or roll something or just turn something. So these are the servo motors. Yeah, even in modern cars, for instance, you have the brake pads, and there is a parking brake. So parking brake, you usually press a small button in the modern car and the car is stopped. But because in the old cars you have to have this little larger lever which you just pull, and you have to apply some force for this because there was a mechanical mechanism. So it was like, there was a mechanical guidance and for that one. But in this one, in this one is there is like a kind of pressing a button, and then the servo motor is activated, and it just moves the brake pad closer to the brake disc, and the car is stopped. So this is how it works. And servo motors, you see here you have the servo, and you need to operate with the servo, right? So if you have the server right, then it means that you can basically say that you just turn the server to this. And here you have server right, server unlock position. So you have unlock or unlock. So it means like what you do. And there is no other screen for the server because the server motor has only two positions, and that is all. So let us see what else. Yeah, you see, so log server attach the server pin. So this is the setup. So actually, we have to go for the setup. So now, and one more library I think we have to discuss is the library which has the safe state. So this is a very interesting library because the safe state library allows you to remember some of the secret codes, and they will be written in the memory of this device. So if you see here, safe state stores the secret code in EEPROM. So what is EEPROM? This is the small memory which is located in every computer at the hardware level. And EEPROM, for example, BIOS is located also in the EEPROM. And in the different industrial microschemes, then EEPROM contains some basic information about the device, and the firmware is embedded into this. So in the computer, we have small EEPROM chips which contain the information about the BIOS. So if you just Google what is EEPROM, so you can write EEPROM. This is a small read-only memory. So if we have to work to see that these are the small microchips like this. You can see also in this, for example, the EEPROM chipset. They're usually in the computer like this, or it could be like in the car industry, in different device industry. So EEPROM contains basic information. Of course, it is the read-only memory, so it's not possible to all the time read and write. You can erase it, you can write there, but there is certain amount of cycles. For example, in the cars, we have to store mileage somewhere, and this mileage is stored in the EEPROMs of different control units. For example, in the control unit of the engine, in the control unit of the light, etc. So you can see there are some kind of entrances about the current mileage of the car, and it's very difficult to change the mileage. So you need to know how to do that. So these EEPROMs, they have little amount of memory, but as we have a device which is a micro scheme which works independently, this is our computer. So in the EEPROM we can save some of the states in order to keep them up later. So that's why we have a save state. So this basically is the save state. So save state is the state for the save. Yes, so they say so. And you can see that here we can have the state save log, and then we can just save it as a log, and then later we can rewrite. So let us see what we have afterwards. Now we have done all the libraries. Here, like initial definition of some constants, for example, servo pin, you know that the servo is connected to the pin 6, and you can see this is especially the pulse width modulation. If you forget what is the pulse width modulation, it is let's say, so imagine, for example, when you had analog lamps, you can have for example, in your home, you can create the lamp shining bright or shining not so bright. So you can easily dim. Yes, so the lamp could be dimmable. But when you come to the problems, for example, to the modern houses, you have LCD lamps, LED lamps usually, yes, but LED lamps, they are not like dimmable always, because they work using the digital signal, and the digital signal is just, there are two positions. There is only 1 and 0, so 0 and 1 all the time. But for example, sometimes we want to have so-called dimmable LED light, because I want, for example, in my flat, light to be a little bit darker. And if I have bought cheap LED lamps, it is not possible to regulate the dimmable things. You know what I'm talking about, yes? But if you want to do it, you can buy a more expensive LED lamp, and then it will be possible to regulate the intensity of light by using the potentiometer. And how to do this, you already spoke with the potentiometer, you worked with the potentiometer in the previous lesson. So it means that potentiometer allows to have this different thing. But what is the pulse width modulation? If you can make dimmable light only if it supports pulse width modulation. So because if it supports pulse width modulation, then you can do the following thing. Look, the signal all the time is going. I can show you, for example, some schemes. I can write pulse width modulation, and you can see that in the pulse width modulation we can try to have some pictures, of course, and you can see, for example, like that picture. You can see here we have a kind of signal, let's say so, and this signal is going like you see here. The small amount of time it is higher, then a lot of time it is low, then it is higher, then it is low. And if you put, for example, the signal is transferred using the clock, internal clock of the processor, because processor all the time they generate impulses, and these impulses transfer the signal. So it means like one certain amount of time you can transfer higher or low signal. So it could be, for example, you in the binary system there is 1 0 0 1 1 1, etc. So you just transfer the sequence of bits. And if you want to have, for example, LED lamp all the time shining at the very higher position, so you need all the time to transfer the highest signal. And then 100% of time the lamp will shine. But if you want the lamp to shine a little bit smaller, so you can do like this. In the digital signal, you cannot make it like voltage, you cannot decrease, because voltage shall be one and the same. but you can decrease the amount of time when the higher bit is transferred. Because you can see here is 1, 2, 3, 4 single clocks. 4 single clocks make one whole cycle, and then it is repeated. And you can see only one part of 4 single clocks is transferring higher bit. The other 3 parts, like, because you can separate these amounts in this case into 4 equal parts. I can, and then it means that only 25% of time during this whole cycle, the higher bit is transferred. And then again, and then again. And it means that the lamp will shine to 25% of its initial brightness, because it will shine only this amount of time, and this amount of time it will not shine. And if you make it like this, that 50%, you can see half of the whole cycle, the lamp is shining. And here, if you have 75%, it is like that. But if you want to shine it to fully 100%, then all the time you need to transfer the higher bit. Is this understandable? What is the pulse width modulation, and how you can understand what is the amount of times you need to see? Do you understand that? Very good. And now, if we return back to the potentiometer, for example, to the potentiometer which you had before, like Pardis showed it. Okay, yeah. So remember, when we had the potentiometer, we needed to have a special function which is called map. And I don't know if we have a map here. I think we don't have the map here, so I can just use again WOKWI.com, and I can open the potentiometer case so that you can see. There is a potentiometer somewhere, I think. So we can try to. Okay, I don't have it here, but do you remember there was a kind of such row in the potentiometer? You had to have a map, and here it was, for example, value, and then it was from 0 to 1023, and here it was from 0 to 255. So it was a kind of a thing like that, yeah. And what does map value mean? So if you take a potentiometer and you attach it to voltage in, there is a pulse width modulation which is called SIG, S-I-G. So you attach it to one of the analog pins. So it means that if you move the potentiometer from one place to another, it moves from 0 to 1023. So it has actually one single byte of information. And you can say that there are, if you just transfer the signal, if you have this amount of times, like you transfer it, you can say that you can regulate it very smoothly, because you can say 1024 different positions you have, and and so on. And then what is else? The next thing is that if you have this amount of things, if you have this amount of things with this pulse width modulation, so you can regulate how intense will be the sinus. So here it was that the lamp intensity was also satisfied. And now let us go backwards, so we know a lot already for this. So let us see the main code. So here we have this is just a function. You can see this function we can call when it's needed, and this function basically wants to do what? It just makes the turning of the servo motor. So it will turn the servo motor to here. And what else? And this function is just remembers the state. So that's all. Remembers the state of the lock. Now the function unlock also turns the servo motor, and that's all. It unlocks and it's done. What is this? Show startup message. So this is very simple function. You can see here startup message. So you activate the LCD. You set the cursor to 4 and 0 positions. So what does it mean? You can see here 0 means that you have the first line. 0 is the first line. and here you have the first. So if we start it, let us try to see. You see, if we start, you can see welcome. So here it is welcome because you have welcome in the fourth position. So this is the row 0. So this is row 0, and this is the position 4. So 1 0 1 2 3 4. This is the column where you start. So from here you start writing welcome. So this is, you just place the cursor to the place where you want to write. And LCD print, it prints what you write here. So if you want, it prints like welcome. Then you have delay. And if you have delay, so you need to wait for a little bit. This is delay of 1000 milliseconds, so you just delay for 1 second. So milliseconds, 1000 milliseconds is 1 second. And then what else? Afterwards, you need to set the cursor to the position 2, so it will be 0, 1, 2, so it's here. And you can see, but not this, you have 2. So here you have, this was the position 0, but here you have the position 2, so you go to the downward, and you can see LCD 0, so it starts from the first one, LCD 0 and 2. And you have a string message, Arduino safe V1, so it means that you have the string message like this. But what is making, so if you see, if you want to replace, you can see it's welcome, and now it is writing very nicely. So Arduino message, you can see once again, so it goes like this, one by one. You can see that. If you want to have such effect, so you need to do the following. You create a message which is string, but then you create like the message which is byte. It is the type of variable. We are using byte type of variable, especially because this requires less amount of memory. If you use int amount here, you will just waste a lot of memory because the memory of this microcontroller is limited. And if you create, for example, instead of byte, you will put int, then int has more memory to remember each single element of the type int. But if you have byte, it requires only one single memory, which is less, and that's why here we are limited to the memory, internal memory of this device. That's why we are trying to use for counters very small amount of, very little amount of types. So you can see, for example, if you want to say what is byte type, you can see byte type. So byte type is, you can see the size of byte type. Usually the byte type is consisting of 8 bits, allowing only 256 different values. So it means that it is not possible to have a string larger than 256 characters. But it gives you an opportunity to use only 8 bits of memory for one single character. But if you have, for example, I mean the position, because here you can see what you do in your code. You do here byte, you do the cycle, and the byte is the iterative variable byte type, which changes from 0 to the length of this message. And logically, we cannot have long messages in such small devices. The maximum we have is 255 symbols, 256. And that's why it's reasonable to use byte for this message, because we will use less memory in order to store this variable. But if we define here, for example, integer variable, which is usual for us when we program, so int, yes, let's just have a look what is int type. You can see byte type gives you 8 bits for one single variable definition, but if we have int type, it gives 4 bytes. Do you understand what is the difference? 8 bits or 4 bytes for one single character. So it means that if in your case you defined here int instead of byte, you will have extra memory for your software. But as you are limited in the memory, it means that you will be overloading this microchip with the memory, and this memory will never be used because it is not possible to create long messages. So it's not reasonable to operate with the int variable here because the length of the message will not be larger than 255, 256 symbols, so characters. So that's why we are using byte here. And here what you do, you can see you print a message I because you have the message, but in this string variable in this language, which is very close to C++, it is possible to address certain characters. So if you have I here, so if you have the zeros character, the first character, the third, and it prints one character of this string, and then it makes a delay of 0.1 second. So it's like very small delay. But if we do it like this, then you can see the effect that it prints one by one. So it's really nice effect, and it is done actually by this function. And what is done delay 500? So it means that you have half a second afterwards to keep this on the screen, and later you can do some other things. I hope it's understandable. So here, for example, but this function, you can see this function is defined here, but if we go to the last setup, and you can see here we have you have setup, and when you set up firstly the screen, you create the log server attach server pin, so you activate the server pins, server motor. Here you have serial begin, and what is the serial begin? It is important to understand that here you can activate a kind of logging file. So this one is self. If you start begin, so here save state logged, it is logged, else unlocked. So it means that here you just remember and you use the save state. So it means that you are making it locked here, because you see if save state is locked, unlocked, then lock, else unlock. So but here it is unlocked. So you just make it unlocked, but if save state is locked, so then you can just lock. And the thing is here you have show startup message. So in the beginning of this program, you just show the startup message, and then you just make the loop, because initially you will make a setup function and then you make a loop function. And you can see here you have save state locked, then you have save locked logic, else you have save unlocked logic. So basically what is needed is all the time you have these two logics, if it is locked or unlocked. And now we have to see what is the self unlock logic. So here we have to find, you can see save locked logic. This is one single function, and this is save unlock logic should be over here. Yeah, this is unlock logic. So these are the main functions basically, because you can either lock or unlock. And here the other things, it is unlock message, and this one already also, this is like set new code. These are the functions which we just call when it's needed. And what we have for now, let us say save unlock logic. So this is the new one. So self lock. If you want to lock, you can see LCD clear. So what you do, you clear the LCD. That's why again it's clear. And then you put the cursor to the 0, 0 position, to this position, and then you have write icon locked character. So you can just write this a locked character. Yeah, and then you can see save locked, but this is save locked, but we have unlocked logic. So then we have to go for unlocked. And here you can see also you have LCD clear. Then because initially we have basically self unlocked logic because it's not remembered. So if we have unlocked logic, we have here LCD clear, so we clear the previous state which was printed. Then now you have else set the cursor here, and you see you write icon unlocked character. So you write this unlocked character, then you set the cursor for 2 positions forward. You can see 2 positions forward, and then 0 means that you don't move it vertically. So it means that you just move it there. And then you have LCD print to lock. So this one is printed here. And then you set the cursor to the last position here, and you just do the same. So it is very simple. Now you have the Boolean variable. Do you know what the Boolean variable is? It is basically the variable which has, let's say, so the Boolean variable basically has only 2 positions, true or false. And it is also good to use Boolean variables sometimes because they have only little amount of memory which is needed. So here, if the save state has code, then the save state has code, Uh, so it means that here now we need to have to know what is the hash code, because you need to save state and let it hash code. You can see. So now we have to see whether we have something like hash code, and here set new code. Wait for the screen. Here you have input secret code. Here you have show startup message. So it means hash code basically for the save state. It is already for the save state. So it means that there is a special library called save state. And you can see that you don't have this anymore somewhere, but you can see that it has code. It's only the Boolean variable. You can see has code, then LCD set cursor, then you have a new code, you print it, and new code needed, you say false, because here you see new code needed is true, but in this case, new code needed is false because you have to enter. And then you see you have the get key, so you activate the key. This is auto variable. And then while key not equal to A and not equal to this, you use like this. You see, you can get the key because you can basically read what you're pressing. And then ready to log. So here you need to find if key is equal A, new code needed, ready to log, set new code. And then here you just take basically ready to log. Then you can create some kind of things that you are printing this in order to ready to log, because you can see here now you can enter to log. You have to press this one, but you can see if you want to press this one, so it's not like that. You see here you have enter, you have A. You see it is not equal to A, it's not equal to B, and they get E. But here if you have it, then if you keys, a new code is needed. So enter the new code. So you just enter 8888, and you can see if you want to enter the new code, then you need to have show wait screen. You can see here 8888. So here now you have this one and safe is locked, so you just put it there. But you won't enter the new code. There is the logic somewhere. Wait. Yeah, you see, so here we came to save locked logic because it is there, but here we have entered the new code. Here is a new code, and you see get key and then set new code. You can see here we have set new code, and if you want to set new code, set code, and here we have confirm new code. So this is like you see set new code. This is a special function. So the function is Boolean. So it means that it will return true or false. Either you enter the code or not enter the code. And you can see this is a clear, set cursor, enter new code. So here you have new code like input secret code. You need to input that. So here you have basically this function, also input secret code. And here you have the font. Let us see what is there and so on. Mm. So here it is like that. And here we can see that we can see basically, yeah, so here input secret code. You see, when you input the secret code, there is also there is like this amount you print and then set the cursor, and here is the logic how you print those numbers, and you can print only from 0 to 9. So, guys, is it understandable this method? And can you please load it and try to understand to watch it and have like a kind of practice with this? Is it clear for you? Or maybe you have it is maybe you have some questions regarding this. No? Then look, now we have this one as the example. And now what we need to do, we need to create just a very simple thing that we need to make it like this. So we have only the keypad without the server, and we have the LCD screen. So first of all, we need to connect the LCD screen to the board ourselves without anything. So we have to try like that. So what we need to do, so here we can delete all these pads. So we can try to enter the WOKWI.com. So we can say WOKWI.com. We can start a new project, and we can start a new project. And here we can start a new project, and here we can have Arduino Uno. And you can see in this case we have to make LCD screen, and you have to take this one, LCD one. You can see this one is the LCD screen. And now we have to connect it. So basically, we need to connect it using basically the things which we have here, and we need to activate it ourselves. So here is the how to say all the information. You can see here. You can read all the things about the pins. And if you want to have the pins, so you have to make it like you have different kind of configurations. So we have 2 lines, 16 characters per line. And here we can see if you want to connect it, this is the pin out. So here are all the possible pins. And here we have standard configuration. So we need to perform the standard configuration according to this device. If we want to do that, we need to understand. So for example, VSS is the ground pin. So what we do, we take and make it. You see here we have VSS. So this one shall be connected to the ground. You can see it also is activated, and I can put it here. So this is VSS is done. I can change the color. So it is like, for example, or maybe gray. So this is for the ground. I hope you understand. Yes, so this is one we did. So now we need to understand what is the next one. And if we go back to the documentation, you can see VDD is necessary for supply voltage. And if we have VDD for supplying voltage, so here you have VDD, here we have voltage, and then here we have this one, this one. So the 5-volt voltage. So we can try to use here, and here. So it means that here we have this part. Then the next thing is Here we have contrast adjustment. It is not simulated. We don't need it. We need RS. This is the common data line. And we can see we can put it to the pin 12. Okay, let's do it for the pin 12. You see RS, so the common data line. So we need to put it to the pin 12. So here we have RS. So we have pin 12. And here we can put it like common data line. So here is like this in brown. Yeah. So this is RS. Then what we need afterwards, we need to write read write connect to ground. So this one shall be just connected to the ground. So we just do it with the connection to the ground. Let us do it like this. Read write, we connect to the ground like this. So here we can put it with the, for example, pink line. Now, what we do afterward, we have the enable screen, so it should be enabled. We have to connect it to the pin 11. So enable to the pin 11, like that. And we can activate it as white, for example. Yeah, so this is like enable. Now, the next thing is we need not parallel data, we need the parallel data like this. So here, this, and this. So 10, 9, 8, 7. Parallel data 4. So we have to put 10, so the 4. So here we have, you see, 0, 1, 2, 3, we don't need. We start from 4. And then we make it like D4 to 10, D5 to 9, D6 to 8, D7 to 7. So let us take D4 to 10, wait, it was to 10, yes, D4 to 10, D5 to 9, D6 to 8, and D7, 7. Okay. D7 to 7. Okay, now A to the backlight anode. So we need to have 5 volts. So we can write A to the 5 volts again. So here, remember, so it was like, here we have the 5 volts, and we can try to backlight anode and backlight cathode to the K. So here we have to write anode to the 5 volts. And this one will be like that. And this one to the ground. It could be like that. Okay, so here, sorry. Okay, I hope it's understandable. And now look, we can have the LCD screen. So we've done the LCD screen. What do we need to do? So here, the thing is the following. If we have the LCD screen, then we need to include let's say so. We need to include the library. We need to include the library, and what we else have to do? We need to include the library, and then we can try to set up. So we need to have LCD begin. Remember here, for instance, we can also read this place. We can see we have to create the liquid crystal. This is important, that we have to put it into that. And it is actually can be done without the setup void. And here we can try to make it like that. And like this. And now we can have LCD begin. And here we can have LCD print. Hello world. You can try to launch it and it shall be already worked. So let us try to see. So now we have to wait a little bit because it's busy, the server. And yeah, sorry, I will have a call and I will just. Алло? Да, 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 быстренько говорите. Да, давай, хорошо. Я тебе, да, всё хорошо. Okay, one moment. So we have to start again. No, you see, so now it's quite busy. Oh, you see, so here we have something. Ah, yeah, you see, so we have to change the library, so we have to install the library. So now it is installed, and then we can find. Yeah, so here the library manager is installed. Yeah, so now we have to again wait. So we have to wait to see the server is quite busy. I don't know, maybe you have done the same at the moment. Does it work with you? Yeah, you're also waiting. Okay. Unfortunately, yes, this is the free simulator and it is quite busy sometimes. So it's if we take like large projects, then it is like, I don't know, sometimes it is like this. So here we have, you see, doesn't name a type liquid. Ah, yeah, liquid crystal. But we have it. Ah, maybe we have to have LCD. Yeah, but here, do we need to? You see, we need, no, we don't need this one. And then liquid crystal, LCD, this is okay for display. Include. So we have this one, include liquid crystal age. Ah, sorry, I have not, this was should be liquid crystal, not liquid crystal age. So we need to start now. We will have to install the library. So we have a liquid crystal. Um, so we need to find liquid crystal, and you can see liquid crystal library should be installed. Okay, and now it shall be fine. So, but again, I need to wait. Sorry for that. Okay, so still waiting. Let's wait. I will wait a little bit again. So we need to wait maybe some 10 seconds more, and then we can try it. Oh, you see now it writes hello world. You can see that. So this is the hello world. Everything is fine. Does it work for you as well? Yeah, you can wait and then you can press cancel and then start again if you see that the arrow moves. Okay, and any other guys, are you successful in this? Then you can see that this is how it works. So if you want to find, for example, different things that we can try to experiment with nice things like adding some characters. For example, here we can try not to write here LCD begin, but we can write it in a loop because here if you write it is in the C tab, but in the loop we can have, for example, different things. And you need to understand that if you want to have LCD clear, then you can write here LCD clear. So there are so many different things like here you can get some commands from this project code, but you can also see the full liquid crystal library. But here you have some kind of characters you can see that you can display and user-defined characters. And there is also, for example, nice thing that you can display. It is the following. You can see here you can create a kind of special thing. Like we will create a heart with you. So you can see if you just copy that part, I can show you how it looks like. And you can see that if we go back to here, if you stop the project, you can create here the character. You can see here is unit 8H. This is a special type of things because here you can see that in LCD you have this little LCD matrices. This is one matrix, another matrix, another matrix, etc. And these matrices have 5 dots. You cannot see that, but they have 5 dots. So here is 5 pixels, and there is 1, 2, 3, 4, 5, 6, 7, 8, and there are 8 pixels in vertical position. So, and then it means that we have the following. You can see if you put 0, it will not shine. If you put 1, it is shining. And then you can create a matrix which will have addresses. Now, if you see that from here, you can have you see that LCD x03. You can see you have create character. You can see here you have heart. This is like the character. So then you can have create character heart. So you will create a character heart, which is like 3. And here you can see that if you make this character here, you can print, and then you can print I love Arduino. So you can put like hexadecimal 3, and that's all. So you can do like that. If you make LCD, so you can delete this part. You can make that like this. You can create LCD character, create char character. So you can make LCD create character, and you can make, for example, 3 and heart, because you are using this heart array. And now, if you want to do that, you can see you have LCD print, and then you can do like that. So you can do in the following way. And look now how it works. So we need to wait a little bit. It's loaded. Oh, we're still waiting. Okay, let's wait. Yeah, we have to wait. Mhm. Yes. Why we use void? This is a very good question. This is very good question, and I will now explain. No, you have to use void. Void is so when you define a function. When you define a function, you have an opportunity to have a function which returns something. And if you have the opportunity to have a function which does not return anything, for example, you see that here some pricing they want to something. Okay, so if you define the function, I can just try to enter, for example, some kind of notepad, and let me say. So here, for example, imagine that you have a code. So here, but do we need to have? Yeah, you see, I love Arduino. It works. So and so if you have a void, so what does it mean? For example, in the code, you can have a function, for example, int sum and a and b. So if I create such function, it is like in abstract programming language. I can create the following, for example, here, return a plus b. So, and then this function basically sums together those numbers. when I want to use these numbers, for example, I have, for example, int int, for example, x equals 5, int y equals 7. Then I can write int z, and I can write z is equal sum of 5 plus 7. So do you understand this code? Yes, you do understand. And you see here is the function, and this function is called here, and you call it with z. Can you write like this? Will you be able to use the following? No, why? No, you cannot use this function without letting it equal to some element. But if you want to use it without making this equal sign, you need to write void. Yeah, and when you create void, you can define what you do there, and if you create void, you don't need to write return. Because it will be like a set of actions which you will do when you just call this function. And you will not be able to, you will not need to set it equal to something. So it will be just void, it will be just making all these functions. And that's all. Now it makes sense, yeah? Welcome. It is really good question because many students, when they start programming, they have a doubt. What is void? Why we need to use void? Because void means nothing, so it means nothing to return. So it's like, yeah, so this is, yeah. Yeah, so basically it doesn't make like outcome itself, but it makes only the actions which you define inside the void, and that's all. Yes, but no, you don't have, because you just define function and it's all. Yes, yes, yes. But in C++, you need to do it. In C, you need to do it. Yes, and in Java, you also have similar things, but you can just but you don't have void as well. But you have different things if you don't put the return, so that there are different logic. Yeah, but it's possible. But so now you understand the meaning of that void, so that you know that in different programming languages you have this. It's called like a procedure and the function. So procedure is void, function is good. So you see, I have managed to finally get the. I have managed to finally get the Arduino, and if you see, I have here the special heart, and I have made it here. You can see this is, and look what is interesting. It is the set of bits. So if you just copy this format, if you just launch a notepad, and you can see here, you can launch the notepad. Wait, yeah, and you can see if I copy it here, you can see that this is a heart. Two items. You have to ignore this because it is like 0b states for binary number. You can put 1 or 0. But you can see that this is the matrix which you have here. And you can see that here you have the first line is empty. So it is 5 zeros there, you can see. Then here there are two of the things. Here there are all the things ready. Here is all the things ready. And this is how you basically create the characters and how you basically create different fonts. So now you can try to make different characters yourself and try to use the same structure which I have here and make not here, for example, you can write here without Arduino. So you can write here I love Arduino. You can write like that all. You can stop here. You can see, and now you can see that you have x03. If you put here, now you can just activate it, and you will see that it will be only heart. But you can create the different things, like not heart. You can create, for example, smile, and you can make it as a smile. So you can create this type of variables, and here you can create, for example, smile. And let us do the smile. So here you can see that you can make like something like smiling face or something. So you can try to figure out how to do that. And probably you can just try to see if you have a smiling face. So here, if you have a 0, if you have, for example, 0, 0, 0, like that, here you can have mm, mm, 0, 0, 0, 0. Here you have like that. Maybe we can do like this, so this will be the smiling face. Let us try to do that. If you, how will it look like? So we can try to copy this part and insert it here, like that, and we can create here like the create character. So we can create a character which is called, for example, 4, and we can try here to make it with the x04. And let us try what will happen. So if it works or not, then we can try to do that. So let's wait. You can see I have two cards, but I have to have here smile. I didn't put here smile. And here we can see, uh, here we can have like that. And let us try to make it so. Okay, something goes wrong here, but let's try again. I don't know if you are also successful in this. So here, unfortunately, we need to have a lot of the things like this. Very long wait. Worked the same, yeah. So you had this smile, yeah, yeah, yeah. And now just think and try to make your own character so that you can have like different. Yeah, thank you for shooting line. You wrote me like this. Yeah, so just try to create your own characters because you are free to design your own pixels. So you have this small pixel art, let's say so now, and you can try to find out what you can do, and then so you know how to program the LCD screen. I don't think we will be able to manage more today. Like I want to attach also the keypad, but the keypad will attach the next lesson. So we can now experiment with the LCD screen. And you can see, so it's not really difficult. And you can also, it is interesting to create how these characters are doing, like going like in this way around. So like appearing and moving. So this one is also a nice thing. But if you want to do it yourself, you need to know how to do that. Yes. So here, unfortunately, then for me, it's very small. So yes, I do. Sure, I will. I will share. Yeah, of course, of course. Yeah, I will share the link. I will now stop recording because anyway we will not do anything new, and I will share the report for you guys.